Fantastic. So everyone, pleasure to meet you. I'm Rob Malnati, lots of familiar faces here. I've been in Portland for going on 20 years now, tangential to video for many of those years. Motorola, Sodexis, and now with thatDot. Looking forward to sharing with you a project we've been working on with a bunch of video-centric folks. It utilizes the new CMCD standard. The whole idea behind this project, though, is to see how we can use new technologies, use standards like CMCD, to bring together all the data that we get from all our different sources and use it to actually help us deliver a better experience to our audience. Importantly, how can we do that in real time so that if we're in the middle of a broadcast, we have the opportunity to actually fix things, solve things before that video is done playing and before the audience leaves to go elsewhere. So I'll be joined with Allan Konar. He's our solution architect out of Boston. Thank you, Allan, for joining us so late. And a special thank you for Nicholas and the AWS contribution to help make all this possible. We really appreciate that. So this is a CMCD proof of concept. We've brought together a bunch of folks. If you're not familiar with Steve Lyons here in town, he works with Mux. He's their head of product. So he's brought the Mux data analytics into the equation here to give us client metrics. We've got TouchStream, who does CDN and CDN edge cache monitoring. It's a synthetic monitoring, so they spin up, virtual browsers and players and test endpoints. AWS Elemental with their live origin and manifest services. The CloudFront CDN, and the Quine open source streaming graph. And so this is a very representative example of the kind of environments that broadcasters use today. They've got many different providers that are part of delivering video. And I can't really think of too many other industries where your critical customer experience is distributed across 4, 5, 6 different vendors and providers. That is a very chaotic situation to manage. And it is not typical for most application delivery. And so it represents a whole bunch of interesting challenges for video broadcasters. The objective of this open source project is to demonstrate capabilities that can be used by you and by others. And so the idea is that Quine, which is the product we're using to bring all this data together and do root cause analysis, this is an open source project. And so we're going to make the technology to do what I'll show tonight available to anyone in the industry that wants to download it and play with it. The yellow highlight there underneath the image is the CMCD data that is being passed from the client back to the CDN and then back, and it is being used to help us link a lot of this data together. So we talked a little bit about the POC platform and the partners involved. Special thanks, again, a call out to Nicholas and AWS for hosting this environment. But it utilizes the live origin service from AWS Elemental. It uses the media packager, which is the manifest service, the CDN CloudFront CDN, sorry, the AWS CloudFront CDN, and Mux was kind enough to take the Dash and HLS players and enable them for us with the CMCD bits to help us tie all this together. And so tying all these data sources together is the Quine open source graph, which we'll talk about in a few minutes. The data sources, it's really important that we think about the idea that we're trying to join data from, in this particular case, 5 different sources and correlate all that data in real time. That in and of itself is a project. The data engineering that goes behind out-of-order data handling and entity resolution across services, constant changes to the schema of the data we get. These are all challenges that all of us face day in, day out in the broadcast space. And we are presenting a solution to help resolve a lot of those challenges. We've also brought in some data enrichment because that's the reality of the world we live in. The idea here was to create as realistic a scenario as possible in showing and demonstrating the use cases. So what is Quine? As I mentioned, I've spent 15 of my 20 years in Portland working in video adjacent or video direct space. I'm now in the data management space. And so Quine is an open source project, quine.io, and it's called a streaming graph. And if you're not familiar with graph technology, a graph is a different kind of data structure. So instead of taking relational data tables and joining them with joins and foreign keys, a graph actually considers the relationships between data as a first-order entity in the database. And we'll talk about what that means in a few minutes. But this is based on graph data technology. It is not a graph database. All right? It's designed to work with streaming data and events, not with data at rest. One of the nice things about Quine is it does graph ETL. And so it mitigates a lot of those data engineering problems associated with out of order, timing, changes to data structure, et cetera. And it executes what we call real-time standing queries. And so traditional databases, you put your data in a database, it's at rest, you then build a batch of it, and you execute a query. A streaming graph, a streaming system, instead applies your queries as filters. And so as all new data arrives into the system, it passes through the queries. And so you basically, every single event as you receive it is passing through all of your queries. This is what allows us to work in the real-time domain. Most of our customers are cybersecurity companies, fraud detection companies, financial companies. This is our first attempt to build a production-grade recipe for video. So CMCD is the technology the key we're using to tie together data across different systems, but not the only one. Some systems are, like for example, the touchstream test, are actually associated with the IPs of the servers of the CDN edge nodes, the origin nodes, et cetera. The media package origin IPs, we use the server IP as well. So I just wanted to share that CMCD is a great way to take client telemetry and combine it with CDN logs, but it does not solve the problem of how do I associate that to my origin servers, my manifest servers, my ad delivery servers, my authentication servers, all the other components of an architecture. And so I'm just trying to make the point that CMCD is a helpful tool for sure, but it is just one piece of the puzzle on how to tie this data together. So let's, and I should have started with a preface. I'm going to go through about 8 slides, and then we're going to show you a demo. Sorry, I should have started with that, I guess. Yeah, start over. So this is our CMCD session ID. This comes from the player. It gets passed back and forth through the CDN logs, the headers, allowing us to then associate the client telemetry with the CDN logs. Unlike a traditional relational database technology, though, a graph allows us to also associate that session ID to the ASN, to the geo, to the HTTP response, to the player type, to the browser type, to the OS of the device. And these aren't details buried down in a table somewhere. In a graph, you can actually make them high-level attributes that are immediately queryable. And that's important because if what you want to ask the system is, are we seeing a lot of rebuffering for this asset, or for this version of the player, or for this version, for this geography, instead of having to do queries to find all that, we're surfacing that in real time in the graph. And so once we have the data in a graph, we can define what we call as a standing query. And so a standing query says, oh, I want to look for sessions that are associated with buffering indicators in the same geo, the same ASN, for the same asset, that are all cache hit success. And so this is the query we build in the system to say, hey, whenever we see examples of sessions that are cache hits, but are experiencing buffering in the same ASN geo for the same asset, generate an alert on that, right? But we don't want to know about every one. We want to know when it's 2% of traffic in that ASN geo, for example. All right? And so this is a tool that allows you to take the business rules that exist in all your different NOC operations personnel's heads and codify it. You know, if you think about how a lot of video observability is done today, people are looking at a Datadog dashboard that is maybe server, you know, metrics, and then they're looking at, you know, the Akamai dashboard of their CDN and the Fastly dashboard of their CDN, and maybe we've spent some money on Splunk and brought some of that together in, you know, the last 10 minutes or an hour. But it's intuition of that NOC operator that is really what's helping us find the root cause of problems. With a system like this, you can take all those failure modes that you know already, that are in spreadsheets and NOC tech heads, and put them in the system. And so now every event that comes into that system is being run through a filter of, does this match any of the 400 failure modes we know about? If it does, then start counting that, and if it becomes significant, and that's up to you to define, is it 1% of your traffic, 2%, 5%? Then generate alerts for me. One of the nice things about a graph technology is when we get that alert, we immediately have access to all the context about, oh, is that all common to one ASN? Is it common to one player? Is it common to one asset? It allows you to very quickly understand the context of that alert. And this is the critical piece that helps your techs understand, oh, geez, it looks like we just rolled out a new version and a new encoding of this asset, and it's failing in a lot of places. Or it's failing on this player. Or it's failing in that node of that CDN, right? So this is what the project does. What that looks like with real video data is this. Oh, that's not very clear, is it? What you're seeing here on the left-hand side is these are all the events we get from the player. These are literally every event from the player associated into a session, and then associated back to a session ID. That session ID is then associated to, you know, an asset, a player type, and we can start to see all the CDN data on the other side. So we're taking our client data, combining it with our CDN data, and then we're going to enrich that with third-party data that's giving us like GeoIP mapping or whatever user-defined functions you may have defined already. And so that's a critical piece of the puzzle here. This is a tool where this is not being presented as a be-all, end-all solution. You drop it in and observability is solved. This is a software tool that you can use to bring data together, build a graph with it, and then start looking for patterns in that data. Importantly, this tool is capable of working at high velocity and with many, many kinds of data and solves a lot of data engineering problems. Okay, so we're going to jump to a demo. In the demo, Allan is going to walk us through the actual real-time platform we have deployed with AWS and all these partners right now. It's going to demonstrate us ingesting data and sessionizing it all. And then we've introduced a couple failure modes. One's a network failure mode that looks like BGP misconfiguration, and the other is a player failure that is introducing buffering. Allan has actually gone and actually forced some of these errors into the system so we have data to look at because the system itself is very light load and doesn't have a lot of problems. So we've forced it to have errors that we can demonstrate. If you want to play along, the Dash and HLS players are right there. So if anyone wants to generate a session during the call, we can probably even find a way to go dig those up right out of the data. All right. So Allan, are you there?
I am.
Excellent. I'm going to pass it back to you. You need to share screen.
I hope you can see what I'm sharing. You seem to have frozen.
We can. No, we can see you just fine.
Awesome sauce.
I'm going to shrink my ridiculous face picture down. So Allan, about 10 minutes, 10 to 12 minutes.
Got it.
Yeah, sorry. I'm going to go full screen. Hold a moment. Hold on. There we go. Okay. Thank you, Allan.
Sure enough. So on the left is the web UI for Quine. On the right is the terminal session that I began running it on. This is all running on my Mac laptop. So you see I pulled in over 9 million records from CloudFront, and then about 59 from Mux. And you'll see that I have these notifications in my console. I configured the system so that when it triggers one of the standing queries, that it displays the output into the console rather than, for example, sending it to Kinesis or to Kafka or to a webhook, just for convenience. But you'll note that what gets generated is this URL that when I click brings up the graph in question. So in this case, we see that two different IP addresses were associated with creating the same or originating the same event. And in fact, if we drill down to that event, we'll see that we have a stream associated with it. We have two different edges that have been associated with it. And in fact, those two different edges are associated with two different pops in two different geos. What makes this really interesting is what Rob was talking about earlier, which is that we receive two records to create this graph. The first one is this one, that is the CDN log. And from the CDN log, we extract information in order to create nodes. Traversing nodes and edges is extremely efficient. By coincidence, the way that memory management happens in terms of addressing, being able to connect edges and nodes maps directly to how they're stored in memory. So it's incredibly quick. What that means is that we can, for example, from this record, see that the ASN was 9009. So I extract that on ingest and create an ASN 9009. I can then see what city it's associated with. Well, in this case, we actually saw that there were originated video requests from 3 different cities over that ASN. What happened here is that we started playing a video and then switched on a VPN so that we switched our geolocation in order to mimic, effectively a BGP issue, like AS being distributed incorrectly. Another type of event that we can mimic, if we want to, are buffers. Or rebuffering events, right? So I can begin to play out a video and then begin to choke out the local buffer. Eventually it'll play out. There we go. Then we put it back online. Hopefully it'll start playing again, and then we'll get another buffering event, so on and so forth. I actually had a couple of examples of the buffering events earlier. I don't anymore. So instead, what I'll do is I will pull up one of our streams that we saw, and I'll show you a little bit of what Rob was talking about in terms of how we deal with the connection of the data, and more importantly, how we match patterns. So one of the key things that Rob had mentioned earlier is that experienced NOC personnel intuit what are the root causes of events based on their experience. We can codify that by creating these patterns and then filling the patterns. Actually, there's a better way to show this. And then we take those patterns and we make them alerts. Not useful again. I'm batting 1,000. Let's try this again. There we go. So we have a handful of streams. With those streams, we have the player info. So remember, aggregated information or correlated information is key here because it helps us to pull together what might be the root cause. Remember, we're talking patterns here. So each of these streams happen to use the -js player. And equally importantly, we can find the host that is associated with this. Sorry, my screen is small, so I'm having problems navigating. And what that lets us do is tie together each of these event types. So earlier, when we were looking at that alert for the BGP issue, another alert type that we would see is one where we see, for example, multiple rendition changes over time or multiple buffer events over time. Now, we are able to put these in chronological order, again, because if we look at the log information that's passed to us, we get a list of events from the player. So what we do is we extract those events and create them as independent nodes, because again, traversing nodes and edges is always going to be faster than looking something up dynamically. And I apologize. I realized I'd paused my ingest stream because I was sitting here with 9 million events populating my database. So here we see an example of one of these rebuffer events that I mentioned. We can find that by following a pattern. So we don't need a counter to say, okay, we've had a rebuffer, we've had a rebuffer, we've had a rebuffer, because ultimately, when you use counters, there's typically windows, time windows associated with those, and we don't want those time windows. So instead what we do is we say, okay, in the order of the stream events, so all of the individual changes in bit rate or pause or seek or rewind, do we have these buffer events? And in fact, we can then go and examine what happened before and after these events, right? So we can take a look at the entire history of this stream playout in a very intuitive way. Now, what I'm showing you is our UI, but typically what you'll see is that these alerts that are sent to a third-party system, to whatever it is that you're already using in your NOC, and they provide this fast mechanism of jumping into the UI to investigate or providing the relevant information, right? We can provide the stream ID, we can provide the associated video information, right? Because we extract that. We can provide what's the associated manifest. And that's interesting for whoever is delivering the stream, as an example. But for whoever it is that is providing the player, that's where you might want to get the player information or the serving host information. So effectively, what we're doing here is we are creating subgraphs of the greater graph. So where we have delivered, actually, where we've delivered this information about a buffering event, this is a subgraph. This is only a part of the entire view of the delivered service, but it's the one that's relevant to the kind of error, and it's configurable. The same way that the BGP error was configurable, what we sent was the singular event and the multiple clients, which really represent source IPs. And we can obviously, from whatever's sent, then drill down further, right? We can say, okay, you know what? Show us the events in chronological order. This is information that we get by traversing the edges and nodes. That's why it's a sub-millisecond response to gather this information. That is kind of the secret sauce of what we do. I'm going to take a pause here. Any questions so far?
got volume.
I'm going to make a comment more than a question, is that this gives me a lot of joy to see that -JS and HLS were using these tests, because it was my principal engineer that put CMCD in both those libraries, as well as Shaka. And to see that happen, and you guys using this and forming this whole graph, my only question is, have we thought about VR for visualization? It's 3D space for these graphs.
Yep.
Okay. Yeah. Oh, there we go. So the visualization aspect is outside the domain of what Quine does. So one of the reasons that TouchStream is in this is they were looking at, could they take this data and visualize it in their virtual NOC, for example, as a working tip. There's also an open source project at Amazon that Lionel had pointed me at that we took a look at. This is very much a work in progress. Yeah, right. Today we've got 3 data sources in here. By next week we'll also have the Elemental live logs and the via CloudWatch, and we'll also have the Elemental manifest. No, we're getting the manifest logs already, I think. So yeah, we're building out more to make this more and more interesting and compelling for folks. But again, this is just a proof of concept. The idea is we want to make this available to the world because we think in our world, graph is the right tool for these kinds of problems. And we don't know anyone that's applying graph to them. So we figured this is an excellent exercise to demonstrate the value and how people could use it to gain insight that could really help them in their business. Yep. 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 I had a great conversation with Brenton from TouchStream this morning about some of the visualization ideas, and he's working on a bunch of stuff. So, yeah. Great. Allan, thanks so much. I think that's really the extent of the demo, right? I mean, it's about bringing this data together in real time from many sources, solving a lot of the data engineering problems associated with doing that, and then being able to watch the data in real time for all these failure modes that we already know about. Like, we know if you're getting buffering, but it's cache misses, we should probably ignore that. If it's lots of rebuffering events in the same ASN, in the same geo, for the same asset, but they're cache hits, then we have something else to think about, right? That's probably worth surfacing and investigating. And when we go to do that investigation, because it's a graph, we can instantly get the context of, oh, well, what player is common across all these issues? What encoding type is common across all these issues? And that's the context that you get from using a graph. And so that's really the extent of our presentation tonight. Sure, Allan, we can get Allan surfaced here. Turn on your camera for a minute, Allan.
Sure. I turned it off because you guys were flickering in and out, but here I am.
Yeah.
Thanks, Allan.
I'm sorry, I had one more slide, which is, go ahead and close that share down, would you? Thank you. Which is that the open source project is Quine.io, and currently we have a CDN cache efficiency monitoring recipe out there that was donated by a Fastly engineer. So any of you that use CDNs and want to see in real time, am I getting efficient use of my edge? Like, what is my hit and my fail ratio? If you want to bring that kind of data in, we actually have a recipe for that already. A recipe in our world is a version of the open source streaming graph with a configuration file that's already designed to pull in data and do a certain kind of analysis. Yep, go ahead.
Sorry, quick question. If I misheard.
Yep.
Did you say that you had already applied this to data streams non-video? Like you were saying security and stuff. Okay, so it's like more mature for that level, and now you're just taking it and applying it to the video aspect.
Yeah, and mature is an interesting word. We don't ever plan to build a video observability product, right? We have a tool, much like you would buy like Kafka or Kinesis, or it's a tool that you can use to build services. Our recipes are contributed by the community from working groups like this that are examples of how to use the tool for a whole bunch of interesting use cases.
Cool.
We've got one that sucks in Ethereum and looks for fraud and tracks fraud. We got another one for Apache logs that looks for troublesome servers. I mean, there's all kinds of interesting recipes that the community has developed.
I came here to get away from Web3, so if we can just, no, I'm just kidding.
Lionel?
Yeah, I had just a quick question. So everything you showed here for the demo is with Quine, the open source project. There's nothing proprietary from thatDot.
Nope.
That's amazing.
Yeah.
It's a great tool. Thank you.
Yeah. Yeah, it's our contribution to the video community. So help us tell the story, and hopefully people will get interested and want to deploy it in production, and then they can come talk to us for enterprise support, like a standard Red Hat model. Yeah. Thank you. Good. Thank you, Allan.